Hi, welcome to the channel. Here I post challenging math problem videos. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today we will do few problems based on the quadratic equation. Okay. The first problem says, and all the problems are paragraph problem. So the first problem says this fx equal to a quadratic equation is given x square plus bx plus c, and it is said that f of minus 1 minus x equal to f of minus 1 plus x. For all real values of r, x belongs to r, and it is given that there are no real roots. So, which means fx is equal to 0 has no real root. And last information is given, that is 4a plus b is greater than 0. So, it is said that this has no real roots, which means this has imaginary roots. Okay. Now this in another on the based on this information, the first question says if alpha is 4a, let's say alpha is 4a minus 2b plus c, beta is 9a plus 3b plus c, and gamma is 9a minus 3b plus c. So it is clearly seen from this equation that this alpha is nothing but, if we put x equal to 2 or x equal to minus 2, so we get the alpha value, which means f of minus 2 is alpha. Similarly, if we put x as 3, so beta will get, so f of 3 is beta, and the last, if we put x as minus 3, we get gamma, so f of minus 3 is gamma. Okay, now we have to check whether these values are what are the orders of this alpha, beta, and gamma. So what can we do is just we, let's say, from this information f of minus 1 minus x, so let's say this is y, we have assumed minus 1 minus x as y, so x equal to minus 1 minus y, and we add minus 1 on both the sides, so we have x minus 1 as minus 2 minus y, so this is f of minus 2 plus y. Okay, so now substitute x is minus 2 plus y, so we have a of minus 2 plus y whole square plus, or we can say beta into b into 2 plus y plus c, so you'll get this is 4a plus ay square plus 4ay minus 2b minus 2y plus minus by plus c. So ay square plus 4a minus by, and last portion is 4a minus 2b plus c. So this is fy. So fx is ax square plus 4a minus bx plus 4a minus 2b plus c. Okay, and it is given as fx as ax square, so this is same as ax square plus bx plus c, so this thing will get cancelled. So we open this equation and solve for this, and c is also get cancelled, so this is 4a minus b x minus bx plus 4a minus 2b. So this is equal to 0. So this is 4a minus 2b x plus 4a minus 2b. So you'll get 4a minus 2b equal to 0 or x equal to minus 1. Okay. So we'll get 4a as 2b. So b equal to 2. We'll get a relation between a and b. So another equation is given, that is 4a plus b is greater than 0. So which means our a is greater than 0. Substituting the value of 2a here, so we'll get a as greater than 0. So which means our equation of this quadratic equation be like this. Okay, where a is positive. Now another information is given as this minus 1 minus x equal to this minus x plus 1, which means x equal to minus 2. Okay, so sorry, 2x equal to minus 2, so x equal to minus 1. Okay, which means our this quadratic equation is symmetrical around this axis. So which means our this equation is symmetrical around x equal to minus 1. So which means now this alpha, beta and gamma. So alpha is x at x equal to minus 2, 3 and minus 3. So which means this is somewhere between, this is 0. This is 1, this is 2, this is 3, this is minus 1, minus 2, minus 3. So we have to check for minus 2, 3 and minus 3. So minus 2 is here. Minus 3 and 3 are okay. So this is minus 3 and this is 3. So which means this f3 is beta, f minus 2 is alpha, and f of minus 3 is gamma. So which means beta is maximum, then minus 3, which means gamma, and then alpha. This is the correct order. So first is beta, then gamma, then alpha, which means option C is correct. And last is if P is B minus 4A. So let's write this. P is B minus 4A. So B is 2A. We have already found out. Okay. This is 2A minus 4A. This is minus 2A. And A is positive. It is given. I have already found out. So which means P is negative, and last is Q. Q is positive, which means P is 2A plus B, that is positive. So this is 4A and this is positive. So PQ is negative. So option A is correct. The next question is, if alpha and beta are the roots of this equation, that is k plus 1 x square minus 20k plus 14 x plus 91k plus 40 equal to 0, and it is given as alpha is less than beta and k is greater than 0, then the which of the following answers are correct? The first is the smaller root alpha lies in the interval and the larger root beta lies in the interval. So it is clearly seen that k is positive. So which means this graph of this quadratic is be like this. It is parabola upward. So let's say this is alpha and this is beta, and we know this is the minimum value of this function fx. So this value is attained at minus b by 2a, and its value is minus d by 4a. So which means if we find the value of x as minus b by 2a, so x can be written as, this is the minimum value, so this x min is minus b means 20k plus 14 divided by k plus 1 2 times. So we will get k plus 1 and taking 2 common, so we get 10k plus 7. Okay, and this alpha value, and this should be lie between alpha and beta. So alpha value is less than this 10k plus 7 by k plus 1, and beta should be greater than 10k plus 7 by k plus 1. Okay, now we'll check for the options. See, this alpha value is always positive because k is positive and beta value is always positive. So let's put the different values of this option, that is f4. So f4 means we put x as 4, so f4 is 16k plus 16 minus 80k minus 56 plus 91k plus 40. So this 56 1640, this will get cancelled and we'll get this here as 16 plus 11 27k. Okay, so f4 is positive as k is positive. Then f7, so f7 is 49k plus 49 minus 140k 98, then 91k plus 40. So we'll get this will get cancelled and this is minus 9. So minus 9 is less than 0. So f4 f7 we have found out, and similarly we'll check for f10 and f13. So f10 is 100k plus 100 minus 100 minus 140 plus 91k plus 40. So this 100 140, this will get cancelled and this is minus 9. This is also negative, and similarly last is f13. So f13 is 169k plus 169 minus 260k minus 182 plus 91k plus 40. So this will get cancelled, and this is 40 minus 13, that is 27. So this is positive. So we'll see this F4 is positive, F7 is negative. So which means 4 should lies between here somewhere. This is 7, and again this is 10, and this is 13. So which means alpha lies in between 4 and 7, and beta lies between 10 and 13. Okay. The next question is fx is given. Fx is x square plus bx plus c, and it attains the least value at x equal to -1. So x equal to -1 attains at the least value, which means that is minus b by 2a. So here a is 1, so which means b equal to 2. Okay, and the graph fx cuts the y-axis at y equal to 2, which means at fx is 2 at x equal to 0. So which means putting the values of fx as 2 and x as 0, so we'll get c. So which means our fx is x square plus 2x plus 2. Okay, the least value of fx, so the least value is minus d by 4a. So fx minimum is minus d by 4a. So minus d means b square minus 4ac. So b square minus 4ac by 2a, sorry, 4a, which means 4, this is 8 minus 4 is 4, 4 by 4 is 1. So option C is correct. Next is f of -2, f of 0, and f of 1. So just substitute fx as f of -2 plus f of 0 and f of 1. So f of -2 means -4 plus 4. This is -4, so will get cancelled. So this is 2 plus f of 0 is 2, and last f of 1 is 5. 9 answer. So option D is correct. And last is fx is equal to a at two distinct real roots, the complete set of the value of fa. So fx equal to a has different real roots. So fx equal to a, so which means fx minus a equal to 0, and our fx is this x square plus 2x minus plus 2 minus a equal to 0, and this has two distinct real root, which means d value is greater than 0. So that means b square minus 4ac should be greater than 0. Okay, so which means this is 4 will get cancelled by taking common, so we'll get 1 minus 2 plus a. So which means a is greater than 1. So a is greater than 1 means a is from 1 to infinite. So option A is correct. Now the next question is, this equation is given, that is log base 2x whole square minus 4 log x base 2 minus m square minus 2m minus 13 equal to 0. And it is given that the real roots are x1 and x2, where x1 is less than x2. So we have to find the values of all sets, all the values of m for which this equation has real roots. So let's say this equation log x base 2 as a. So which means our equation become this. So to find the real roots of this equation, which means d should be greater than 0. So which means that is b square. B square means 16 minus 4ac. This should be greater than 0. So if we take 4 common, so it will get 4 plus m square plus 2m plus 13 should be greater than 0. So that is m square plus 2m plus 17 is greater than 0. So to check the values of m, if we find the value of d of this equation, so d is b square minus 4ac, which is less than 0, which means this value gives uh, imaginary roots, which means this is always greater than 0. So which means that for all values of m, this is always positive. So the set of all values of n, the answer is this. So m is lies between minus infinite to plus infinite. Next is the sum of the maximum values of x1 and the minimum values of x2 is. Okay, so let's write this equation. So we have this quadratic equation, so which means this is the d value. So a is minus b, so this is 4 plus or minus under root, this is 4m square plus 2m plus 13 plus 16 by 2. This is 4 plus or minus, taking 4 common, so we'll get 2 outside. So inside this is this expression, this is 2m plus 17 by 2. So if we divide by 2, so we'll get 2 plus or minus under root this expression. So m square plus 2m plus 17. So we can write this as this is 1 plus 16. So which means 2 plus or minus under root m plus 1 whole square plus 4 square. Okay, so this is a. So this is a, and a is log x base 2. So which means x equal to either 2 to the power 2 plus under root m plus 1 whole square plus 4 square, or 2 to the power 2 minus under root m plus 1 whole square plus 4 square. Okay, so obviously x1 is less than x2, so which means this is x2 and this is x1. Okay, so we have to find the maximum value of x1. So the maximum value of x1 and minimum value of x2. So x2 minimum is, so this value is minimum when m is equal to 0, because all this is always positive. So which means this is 2 to the power 2 plus putting m as 0. So we'll get or m as -1, sorry, not m equal to 0. This complete expression becomes 0 and m lies between minus infinity to plus infinity. So which means by putting to get the minimum value, we'll get m plus 1 should be 0. So m plus 1 should be 0. That means this is 4 square, this is 4. So this is 2 to the power 6. And last x1 at maximum. So yes, the maximum value of x1. So x1 will get maximum at similarly because this is the negative sign. So to get this maximum value, we'll get this to be minimum, this to be minimum. So to get this to be minimum, again m plus 1 should be 0. So m plus 1 should be 0. We'll get x1 maximum. So x1 maximum is 2 to the power 2 minus 4. So this is 2 to the power minus 2. So now we have to add this. So x2 minimum plus x1 maximum. This is 2 to the power 6 plus 2 to the power minus 2, that is 1 by 2 to the power 2. So 1 by 2 to the power 2, 2 to the power 8 plus 1. So this is 4 and this is 2 to the power 8 means 256, 257. So option D is correct. Next question is a biquadratic equation is given, that is x to the power 4 minus 2x cube minus 3x square plus 4x minus 1 equal to 0. And this has 4 distinct real root, and we have two, and another information is given, that is product of two roots are unity. So we have to find the values of x1, x2, and similarly for the next question. So what we can do is we divide this expression by x square. So we'll get x square minus 2 by, sorry, 2x minus 3 plus 4 by x square, 4 by x and minus 1 by x square. And again, we can write 3 as minus 1 plus 1 minus 4. So this can be written as, this is 4 minus 6 and this is 4. Okay, so what we have here is x minus 1 whole square, and this is 1 by x minus 2 whole square. Okay, so if we open it, so we can write x minus 1 plus 1 by x minus 2, and second is x minus 1 minus 1 by x plus 2. So which means we have two quadratic equation, that is x square minus 3x plus 1, and second quadratic is x square minus x minus 1 plus x minus 1. Yes. Now we have to solve this individual quadratic. So we'll get x1, x2, x3, and x4. So for the first equation, x is minus b plus or minus b square minus 4ac by 2a. So which means 3 plus or minus root 5 by 2. And for the second equation, x is minus 1 plus or minus b square minus 4ac by 2a. So minus 1 plus or minus root 5 by 2. So which means we have to check what are the x1, x2, x3 and x4. So x1, x2, x3 and x4 are in increasing order. So which means x4 is the maximum value. So that is, and just let me write two equations. So first one is 3 root 5 minus 2, 3 minus, sorry, 3 plus root 5 by 2 and 3 minus root 5 by 2. And second expression is 1 plus root 5 by 2 and minus 1 minus root 5 by 2. So it is obvious that this is x4. This is the maximum value. And this is x1 because this is the minimum value. So now we have to check for x2 and x3. So let's take x root 5. Root 5 means 2.236. So let's say 2.2 and plus minus 1. So this is 1.1 by 2. This is 0.5 approximately. So this is 0.6, 0.5. And this is 3 minus root 5, 3 minus 2.23. So 2.2 means 0.08. So by 2, 0.04. No, sorry, 1 point something. So 1.1 by 0.5. Okay, okay. Let's take another value, 2.236. So 2.24 we can take. So 1.2. So this is 0.6. So this is 0.6. So obviously this is x2. Sorry, this is x3 and this is x2. Okay, so let's write this expressions are there. Okay, let me write it. So these are the x1, x2, x3 and x4. So what we have to find is this x1, x2, x1, x3, x2, x4 and x3, x4. So x1, x2, x1, x3, then x2, x4 and x3, x4. Yes. So which means we take x1 common. So this is x2 plus x3 and again x4 common, so x2 plus x3. So which means we have to find the value of x1 plus x4 and x2 plus x3. Now put the value of x1 plus x4. So x1 plus x4 means minus root 5 will get cancelled. So 3 minus 1 by 2. So 3 minus 1 by 2 means 2 by 2, 1. So this is 1. So this is the first value and then x2 plus x3. So x2 plus x3 again, this root 5 will get cancelled. So 3 minus 1. So this is again 1. So this is 1. So the first answer is option B. Next is x2 cube plus x4 cube. Okay. So x2 cube plus x4 cube. So x2 plus x4 whole cube minus 3 x2 x4, then x2 plus x4. Okay, so x2 and x4 are the conjugate, so which means this root 5 will get cancelled. So 3 cube means 27 minus 3. This product is c by a. Okay, no, and so this is minus 3 by 1 means 1 and this is again minus b by a. So this is 3. So this is 9. Okay, this is minus 27. Okay, So which means this is minus 21. No, not minus 20, minus 20, minus 80. Just a minute. This is minus 18. I think D should be the answer. I have made some mistakes in the calculation. I think just a minute. This is minus B by this is plus 20. Just a minute. X2 plus X4. This will get cancelled. So 3Q is 27. Okay, so this is plus. Just this is plus, and this is again plus. Okay. Yes. There it is plus. Okay. So this is 20 plus 18. Yes. So option D is correct. Okay, the next question is fx is a polynomial of degree 5 with the leading coefficient is unity, and it is given that f1 is 5, f2 is 4, f3 is 3, f4 is 2, and f5 is 1. Then few questions are given based on this information. So let's say fx is a 5-degree equation and whose unit value, the leading coefficient is 1, which means if we can write fx as k into x minus x1, x minus x2, x minus x3, x minus x4, and x minus x5. So we can simply say that k equal to 1. Okay. So next is this f1 is 5, f2 is 4, so on. So we can write fx as 6 minus x. Now put the value of f1. So f1 is 5. Similarly, f2 is 4. So fx minus this 6 minus x equal to 0. So which means if this complete expression became 0, if we write fx minus 6 minus x as x minus 1, x minus 2, x minus 3, x minus 4, and x minus 5. Okay, so by substituting each value of x as 1, 2, 5, this is 0. So which means fx can be written as x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, and then 6 minus x. So this is our desired 5-degree equation. So fx is x to the power 5, then sigma of all the values of n roots. So this is, let's say 1, 1, 2, 3, 4, 5. So sigma 1. So let's say this is alpha. Okay. So this is, and last this is there. Sorry, no, this is x to the power 4. Just a minute. Then next is plus sigma alpha beta x cube minus sigma alpha beta gamma x to the power 4. Then plus sigma alpha beta gamma delta, taking 4 at a time, x, and this is minus x, plus the last is the product of this equation. So last is minus product is pi of alpha. Okay, and plus 6. So this is the polynomial expression of 5-degree. So now we have to find the value of f6. So putting first f6 is 6 minus 1, 6 minus 2. So which means This is 1, 2, 3, 4, and 5. Okay, put the value of 6 here, so we'll get 126 as. So option A is correct. Then the sum of the root of fx. The sum of the root of fx is this minus b by a. This is the first term just. So this is sigma alpha. So sigma alpha means 1, 2, 3, 4, 5. Okay, so this is 15. So option A is correct again. No, minus 15. No, this minus is there. Minus of uh, minus minus b by a. Okay. So this is minus of minus b by a. So this is already minus is there. So this is 15. And last is the product. Product is this already. We have find out. Product is this 120. So product is A. Uh, okay, I have missed this part. Actually, product is obviously 120, and this is there. So plus 6 is there. So which means this is minus 120. The product is minus 120 plus 6. So that is minus 140. Okay. So option D is correct. Now, this is the last question of this video. So the problem says a cubic equation is given, that is x cube minus x square plus x minus x square sine theta plus x minus x square cos theta plus x minus 1 sine theta cos theta equal to 0, and whose roots are alpha, beta, and gamma. So we have to find the value of alpha square by 2, alpha by 2 whole square, beta by 2 whole square, and gamma by 2 whole square. So let's solve it. So we take x square common, so we have x minus 1. Now again we take minus x common, so we will get x minus 1 sine theta plus cos theta from similar expression. Okay, so last is x minus 1 sine theta cos theta. Okay, so taking x minus common from the complete expression, so we'll get x square minus x sine theta plus cos theta, and this is sine theta cos theta. Okay, so we have x as 1, and another expression is x square minus x sine theta minus x cos theta plus sine theta cos theta, which means this is nothing but x minus sine theta into x minus cos theta. Okay, so you'll get x as sine theta and cos theta. Okay, so our alpha is, let's say, 1, beta is sine theta, and gamma is cos theta. Okay, so the first expression is alpha square by 2 means 1 by 4, alpha by 2 plus beta by 2 plus gamma by 2 square of all the values. So this is 1 by 4. This is again 1 by 4 sine square theta plus 1 by 4 cos square theta. So 1 by 4 sine square theta plus cos square theta is 1. So this is 1 by 2. So first answer is option B. Next is the number of values of sine theta for which at least two roots are equal. Okay, so these two roots are equal. So let's draw the graph of sine theta and cos theta in between 0 to 2 pi. Okay, so this is sine theta, and let's draw the graph of cos theta. So this is cos theta. Okay, let me draw it clearly. Okay. So this is 0, this is pi, and this is 2 pi. So it is asked that these two values, at least two of the roots are equal. So sine theta, cos theta is equal at this point and this point. Okay, so this is two value, and last is if we take one with sine theta and cos theta, so we have 1 point here, 1 point here, and last point is here. So which means we have five roots, which are two roots are equal. So which means the option of this question is the answer to this question is option D. Okay, so this is all for the day. See you in the next video.